What up, mathletes? Whoop, whoop. All right, we're going to get on. This is 7.1, and the learning target is I will solve a system of equations by graphing. I will solve a system of equations by graphing. There you go. And this is your warm-up. Go ahead and take a minute, pause this, so you can try it out. You got to check these solutions. But I'm going to move on. You ready? Set? Okay. So it says determine whether each ordered pair is a solution of y equals 3x, a solution of y equals 2x minus 2, a solution of both equations, or a solution of neither. So to check if it's a solution, we just plug it in. So if this is my x and this is my y, for y equals 3x, I would have 2 equals 3 times 2, which is 6. Does 2 equal 6? Nope. So it's not a solution of y equals 3x. Let's try y equals 2x minus 2. That would be 2 equals 2 times 2 minus 2, which is 4. What's 4 minus 2? It's 2. Does 2 equal 2? Yes, it does. So this is a solution for y equals 2x minus 2. All right, let's check negative 2, negative 6. So again, I'm going to plug it right in. Negative 6 equals 3 times negative 2. 3 times negative 2 is negative 6, so negative 6 equals negative 6. Check. It does work for y equals 3x. Let's see if it works for the other one as well. That would be negative 6 equals 2 times negative 2 minus 2, which that's negative 4. So negative 4 minus 2 is negative 6, which means negative 6 equals negative 6. Check. So it's a both. This is both, right? Probably should circle the answer. Let's try this one. By the way, if you weren't sure how to do this and I just clued you in by plugging them in, go ahead and pause it again. See if you can do the last two on your own. But let's get rolling nonetheless. So this is my y. So I'm going to have 6 equals 3 times 2. Which is 6 equals 6. That's check. Works for that one. Let's see if it works for the last one, which is 6 equals 2 times 2 minus 2. And that is 4. What's 4 minus 2? That's 6 equals 2, which does not work. That's not true. So this only works for y equals 3x. And then last but not least, 4 equals 3 times 1. Well, clearly not. 4 does not equal 3. That doesn't work. Let's try the last one. 4 equals 2 times 1 minus 2. Well, 2 minus 2 is 0. 4 does not equal 0. So this is neither. Looks like we have one of each. A y equals 2x minus 2, a both, a y equals 3x, and a neither. Okay? All right. It's that time. We're going to write down some definitions, so just hang with me. And I didn't give you tons of room, but hopefully this is enough. I tried to adjust it accordingly so you guys would have enough room. But we have, for systems of equations, that is a set of 2 or more equations with the same variables. Okay? So a system of equations is a set of 2 or more equations with the same variables. All right, consistent. A system of equations, I should put an S there, with at least one ordered pair that satisfies both equations. One ordered pair that satisfies both equations. Don't worry, I'll explain all this in the coming moments. And again, as I'm going along, pause at times. Since we're on video, I know you're going to have the ability to pause it. That's why I'm not waiting that much in between. And an inconsistent system is a system of equations with no ordered pair that satisfies both equations. System of equations with no ordered pair that satisfies both equations. That shorthand's a lot nicer, I know. Okay, so again, pause it, write down everything, and then let's keep rolling. So we're going to talk about, just define some of the graphs of systems of equations terminology. So here's the terminology we're going to use. Number one, we're talking about when there is one solution, infinite solutions, and no solution. Okay? So when a system of equations has one solution, we call it consistent and independent. They don't affect each other. The two lines don't affect each other. They're just what they are. And you can see it right here. They're consistent in that they meet right here. There is a answer that applies to both of them. So that value right there was that value. 1, 3. 1, 3 works in both of these equations. Okay? And we can see that because right here, look at that. 3 equals, is that 1, 3? No, it's 1, 2. Duh. 1, 2. You guys are like, what? So 2 equals 2 times 1, which equals 2. Yep, that works. And then we have 2 equals negative 1 plus 3. What's negative 1 plus 3? Well, that's 2. 2 equals 2. Works on both of those. Okay, so that's perfect. All right, so let's look at infinite solutions. Infinite solutions is called consistent because there is at least one solution, right? It says with at least one solution up here, with at least one solution for consistent. So consistent, but dependent, not independent. And why is that? Because they're the same line. So look right here. Notice on this, for y equals 2x up top, on the bottom one, I can add 4 to both sides. What do I end up with? Y equals 2x, which is the same as up here. They're the same line. So because of that, they're on top of each other. They're dependent upon each other. When one moves, the other moves. Okay? And the last but not least one right here is no solution. No solution is inconsistent. And why is it inconsistent? Well, what do we notice here? Do you notice how they have the same slope right here? These two lines are parallel. Because they're parallel, they're traveling in the same direction. So I'll just talk about here. They're traveling in the same direction and will never cross each other. You have to be not parallel to cross at some point. They're parallel. They're going the same way. Okay? All right. Make sure you have this all written down. Pause it if you need to. This graph, the equation should be on the other side of the paper, but clearly I missed that.